In the previous lesson, we learned about chemical equilibrium, and we learned how it is expressed in an equilibrium constant, which is represented by the letter K. In this lesson, we are going to look at the values of the letter K in order to determine if the reaction favors the formation of the reactant or the formation of the product. Before we do that, let's look at an equation that represents an equilibrium reaction. We have R and P. R represent the reactant and P represent the product, where the lowercase r and the lowercase b represent their coefficient. And we look at the expression of K, we know that on top we would have the product, and on the bottom we have the reactant. So by looking at the values of K, we can determine the values of product and reactant. For instance, if we have the values of K equal to 1, and the only way that's possible is that the concentration of the product and the concentration of the reactant are the same, so they cancel each other equal to 1. That means this reaction equally favors the formation of both the product and reactant, which makes sense. Now if we look at the particulate diagram, we would see that the number of product and reactant particles will be the same. So I'm going to use R and P to represent our substances in terms of reactant and product. So I have R right there and R, and now I have P as product. Notice how the number of particles of reactant and product are equal to each other. Now what happens when I have K is greater than 1? And one way that K is greater than 1, that is because the values of the product is increasing where the reactant remain the same. So therefore, we would see that we would have a lot of product in this reaction, which makes sense. So therefore, we can say that it is favor the formation of the product, and therefore, in a particulate diagram, it has more product particle than the reactant. If we draw the particulate diagram, we would have R as our reactant, and we would have a lot of product, represented by the letter P. Now what if we have the opposite of K greater than 1, where we have K is less than 1? We would see the opposite of it. We can say that instead of favor the product formation, we now is to favor the formation of the reactant, which makes sense. The only way that K can be less than 1 is that this value right here, the reactant, would increase. Therefore, we would have a number divided by a larger number, so therefore, making K less than 1. So in this case, if we look at the particulate diagram, this is supposed to be particulate, not particular diagram, it would have more reactant particle than product. So our R would be a lot when compared to P, just a few of it. So I want to draw my R everywhere. And this is how we use the values of K